Okay, so question 14 looks like this, and I suspect that this is one that you guys are asking about, because if you try U substitution, you have to pick out a U, and no matter what U you pick out, it's not going to work out for you, because this is not a straight U substitution. You can't integrate everything with U substitution. Some integration you have to know from memorization. So I would say that you had no chance of getting this one right, except that I had just given you a handout on the derivative of inverse trig functions. And so of course you needed to have that at some point anyway, but I made a point to give it to you guys last time. Of those two, which ones did I say were most likely to show up? And sine is that, I believe. Okay, and tangent. It's minus. Okay. And then tangent is this one. So I can't promise you they won't ask one of the other four, but looking through lots and lots and lots and lots of release questions, these are the only two that I've ever seen. So which one is this one close to? It's almost this one. So since U substitution didn't work out, we got to do something else. And the something else on this question is to try to match it up to this. Well, what's different about it? Right, we need this to be a 1. So let's factor out the 4. And then I can bring that out front because it's just a constant. Okay, now it looks pretty close to this, but what's different is the one more change we need to make. This is supposed to have, whatever you're plugging in the inverse tangent is the thing that's supposed to be squared. Is the x being squared here? Is the 1/4 being squared? No. So we want to change this. Let's not call it 1/4 x squared. Let's call it 1/2 x squared. Do you see how now the whole thing is something being squared? So now this, well, we've got the 1/4. This fits the pattern of inverse tangent. I've got 1 over 1 plus something squared. So inverse tangent. And the something squared is what you're taking the derivative of inverse tangent of. So that would be 1/2 x. We're integrating, so we need a plus c. But this is going to create some chain rule here. Chain rule would be multiplied by what? Okay, and how do you balance out multiplying by a half? Okay, so to balance that out, multiply by 2. So this reduces to this. And then that's where the answer comes from. So you have to know the derivative of inverse tangent well enough to recognize that that's possible. You had to factor out the 4 and rewrite this as something squared before you could plug it into that formula. You had to recognize that there was going to be chain rule and to multiply by 2 to balance out the chain rule. And then you were to the answer.